Because if you do that, you can overcome Alzheimer's, you can overcome respiratory viral infections, bacterial infections, you can maintain normal erections, maintain normal blood pressure, metabolic activity. You have to look at the data. So nitric oxide is the longevity molecule, because without nitric oxide, we get shorter telomeres, less mitochondria, and less stem cells in circulation. So we don't repair and heal, and we're regenerative by nature. We just need to give the body the signal that it needs to regenerate, mobilize our own stem cells, and that's what nitric oxide is.
Dr. Bryan has studied in some of the most prestigious medical research facilities around the world. He was a fellow in Boston University School of Medicine. All this makes Dr. Nathan Bryan an international leader in molecular medicine, and his course of study and research make him the leading expert in nitric oxide biochemistry.
50% of the men that are prescribed Viagra or Cialis don't respond with better erections. And it's because their body's not making enough nitric oxide to activate this second messenger system. If we go upstream and improve nitric oxide production, now you can make non-responders responsive to that therapy. Or...
Hi, my name is Chris Burris. I'm a longevity expert and the chief scientist at a lab focused on a longevity molecule. My primary focus is to help people live longer and better lives with science. Make sure to subscribe and share so you and your friends can live longer and better, so you and your friends can live beyond the norms.
Hi, and welcome to the next episode of the Live Beyond the Norms Health and Longevity podcast. Our next guest has been on my radar for quite some time. I actually bumped into him at Ben Azadi's recent Metabolic Freedom book launch, so it's kind of cool that I already have a selfie with Dr. Bryan. A little bit about Dr. Nathan Bryan. Dr. Bryan has studied in some of the most prestigious medical research facilities around the world. With his bachelor's in biochemistry from the University of Texas at Austin, his PhD, including a Dean's Award for Excellence in Research from Louisiana State University School of Medicine. He was a fellow in Boston University School of Medicine. And here's my favorite part. Dr. Bryan was recruited by a Nobel Prize laureate, Farid Murad, to work in the famous Houston Medical Center. Houston is where we are based, and actually where the ESS60 molecule was discovered. All this makes Dr. Nathan Bryan an international leader in molecular medicine, and his course of study and research make him a leading expert, if not the leading expert, in nitric oxide biochemistry. As an author, his most popular book, The Secret of Nitric Oxide, Bringing the Science to Life, his focus through his company, N101, is bringing understanding of the value of nitric oxide, and by the byline of N101, which says, the science of age defiance, which I love, to the masses. Dr. Bryan, thank you so much for joining us today.
It's great to be with you, Chris. Good to see you again.
All right, so before we jump into your area of expertise, I like to go further back. And actually from your book, I know you're comfortable talking about this. So what was it like growing up, little Nathan? Where did you grow up? What were your parents like? If there was some event or someone you could pinpoint as the reason you would ultimately become a medical expert, a nitric oxide scientist, an author, an entrepreneur, what or who might that be?
Well, I'm a small town Texas boy. Grew up a town of about 1,000 people. Went to a small 3A school, and when I was 10 years old, my dad had a car accident and left him paralyzed from the waist down. So that was kind of the certainly a memorable moment, and changed the course of not only my dad's life but my life of my brothers and I. And so, we saw early on. This was 1984, and the standard of care really failed my dad. I mean, he was sick all the time. He didn't know if he was going to live from the car accident, developed ulcers, non-healing wounds that, had trouble healing, almost died several times. And so seeing that process really having an impression on me early in life, and then in high school and college, I always had an interest in science and math and medicine. And so that really kind of forged my way, and, try to understand how can we do better? And then, life's a journey. My career's been a journey, and now we're on that next stage. But, my motivation was really to understand the mechanism of human disease, where we could develop rational therapies, safe and effective therapies, understanding the biochemistry, understanding the physiology, the pathology that occurs in many different diseases. And once you had an understanding of that, then I thought, well, now we can develop rational therapies. And, interestingly, nitric oxide kind of was that leading principle and that new science back from 25 years ago that allowed us to really understand many chronic diseases, and now to develop rational therapies for those. So that was been my guiding principle, was to, as a personal journey, understanding, how do we improve my dad's condition? How do we improve, sick people all over the world by understanding the physiology and addressing those basic root cause mechanisms.
Excellent. And we will jump into nitric oxide. In your book, the Secret of Nitric Oxide, your second foreword, by the way, you have 3 forewords from amazing people, is from Antonio Novello, the 14th U.S. Surgeon General. Like, great accomplishment to have her writing forewords in her book. She quotes the very famous, "What does not kill you makes you stronger." And then your first chapter, which is about you, seems to be your description of life throwing everything at you, effectively trying to kill you, including in your book, you share your stepmother holding a .38 special to your head at some point. Yeah. Can you share some of those tough early years with the audience and how those tough experiences kind of shaped your professional life?
Well, yeah, I think I certainly had an unconventional childhood and an upbringing. My parents divorced when I was, I think, 5 or 6 years old. We had a divided household. For a time I lived with my mom, my brother lived with my dad, so we were completely split. And then, everybody has their own problems. And so I've never used this as an excuse or a crutch. It's just, my belief was it's not what happens to you that matters. It's how you respond to what happens to you that matters. But, we grew up and there was alcoholism in our house and, living with my dad and stepmom, a very violent relationship. And obviously that spilled over to, conflicts with us. And, it's, certainly having a pistol held to your head at 11, 12 years old leaves an impression on you. But, I always was believed that God had a plan for me and my brother and my family. And, we just had to stay the course and, survive these really tough times and keep our head down and focus on, what we were meant to do. And I think I may have quoted this in the book. The 2 most important dates in people's lives are the date you were born and the day you realize why you were born. And so I think the earlier you can figure that out, then you really just have to, put your head down. Everybody deals with diversity. So these things happen to me, but, we learn from them. And I realized early on that God had a plan for me and I had to keep moving forward and just, live to serve and, figure out what that plan was and how God was going to put me on this path to do great things. And so I've always believed that, but it was never an excuse. I could have made excuses for a lot of things in life, but I never used that as an excuse.
Can you think of anything because there are people who have had similar, worse, even not as bad situations who will end up using that as an excuse. Was there any kind of person who guided you to kind of shepherd you in the direction of like, hey, you could, whatever, be sad, you could, wallow in this, or you could kind of move forward? Was there any person who kind of had that impact on you?
I can't pinpoint one person, but I had a really good support group around me. Again, growing up in a small town, the people in the community really come around and provide support for families. And that's really the thing you can't ever, you don't get this in big cities, but small rural communities, especially where I grew up in Texas, community always steps up. And, I was living alone all through high school. Had my own apartment when I was a sophomore in high school. I worked, paid my own bills. But really the counselors and the teachers who understood my kind of unique position, provided guidance. They was always encouraging. I made good grades. I was, a smart kid. I didn't have to study. If I read it and wrote it down, I always remembered it. So I was a good student. Academically, I wasn't always a good student. I got into a lot of trouble. But when I look back and, 15-year-old kid living by himself with no adult supervision, you get into some trouble. But, the counselors, the teachers, the support group around this small community encouraged me, kind of kept me on the right path and said, look, you should go into science or engineering because you're really smart at math and science, and that should be what you would do. But so I don't think there was any one person. I think it was a community and the support group I had around me. And
maybe it's the embodiment of it. It takes a village, right? Like
absolutely.
That sounds what
and it's yeah.
So they're encouraging you to go for math and science. Talk about like you enter graduate school from this tough background. Like how does that happen? Because that's certainly a background that could have easily folded into never going to college.
Yeah. I'll tell you how naive I was. I grew up in a very small town, And so I got accepted to the University of Texas. And so I went to Austin and, enrolled in civil engineering because that was what my counselors advised me to do, the School of Engineering. So I got there, I took like the first semester, maybe a year of classes, and I go to my counselor and I go, what does an engineer do? Civil engineer.
You're like, I'm enrolled. What
I'm in
am
this
I
program. What do we do? And they go, well, they build things, build buildings, build bridges. And I go, oh, I don't want to do that. That doesn't interest me at all. So then I changed into the College of Natural Science and started a degree in biochemistry. And, again, had a professor, John Robertus, who, allowed me to do undergraduate research in biomedical science and natural science. And I fell in love with the research and discovery and, the ability to ask any question that you want and then design an experiment to answer that question. For me, that complete intellectual freedom to do that was what drew me into the basic sciences. I got married at the time, like 20, 21 years old, again, way too young, and really not the responsibility at a point in my life where I had the responsibility to care for a family, a spouse, because I was in school, didn't have any money, was broke, working 40 hours a week on top of taking 15 hours a semester. And obviously that turned up being a disastrous situation, ended up in divorce. And, I knew once I had a degree in biochemistry, when you start to test the job market, there's not a lot of opportunity for a Bachelor of Science degree in biochemistry. And so I quickly realized that I needed to further my education. And I didn't have a lot of support from my wife at the time because she wanted me to go out and earn a living because I'd spent 4 years in college and, we were broke and was thought, well, you got a degree from University of Texas, you can go out and make a good living. Well, that never really came to fruition. So then I enrolled in a PhD program in biochemistry, biophysics at Texas A&M. And, that's when the marriage fell apart. I quit the program and then, really tried to find my way for the next several years. And then, I ended up at LSU School of Medicine in Shreveport, where I think that really was the pivotal moment in my career because I was introduced to the science of nitric oxide. I fell under an extremely, helpful mentor, Dr. Martin Feelish. Met the guys who won the Nobel Prize that had just been awarded for the discovery of nitric oxide. And that really set my path. And for the first time, I think, in my adult life, I felt like I had a clear direction and a clear purpose and just laser focused, put my head down, worked alongside a good friend, Tino Shrasov, who was an MD, PhD cardiologist, and really helped develop the work ethic that it requires to be successful in basic science and academia. So again, all these people came together, I think, at the right time in my life, to kind of keep me in doing that. So when I look back and people go, well, how did you get here? And it's like, I could have never scripted this, right?
Yeah.
I realize how little control I have, and I think probably most of us have in our career. And then I think, again, I'm a very faithful person. And I believe that, God puts people in our life at the right time to direct us and accomplish what we hope to accomplish and live a servant's heart, live with a servant's heart.
So as you're pursuing your advanced degree, you have the opportunity, I think you ended up going to dinner with a Nobel laureate, the one who discovered nitric oxide. And then you get this chance after your advanced degree to be interviewed by Dr. Murad. Had you been following his work since then? And how nervous were you going into that interview? And I think he even disagreed with some of the data that you had in that interview.
No, look, these guys, when you're at that stage, you're starstruck because a Nobel Prize is like the highest accolade one could ever achieve in any discipline. So these guys were the heroes, my heroes in the field. And so I met all three of them at a scientific conference in Prague in 2001. So it's 3 years after the Nobel Prize. I was a second year student and really had the chance to interact and rub elbows and ask questions and, learn their story of discovery, the life-changing discoveries that changes humanity. I mean, that was the basis for a Nobel Prize. So yeah, I had a chance to go and have dinner with Lou Ignarro when I was a student, and then met Fred Murad, Bob Furchcott at that meeting. But so I was obviously aware of their work. They were following my work, unbeknownst to me, because we made a lot of discoveries early on, and I think I finished my PhD in less than 2 years. And then went on to Boston, published, half a dozen papers. I think the first couple of years. And then, when I was looking to start my own independent research career, I'd met Dr. Murad a couple of times at some scientific conferences, and they had a faculty position that was opening up at the Institute of Molecular Medicine, and I actually reached out to him to apply for that position, and he flew me in from Boston and spent a day with him and gave a departmental seminar. And I presented a lot of unpublished data that we were working on that I thought was going to be transformative to the field. And at the end of my presentation, he says, "Look, I don't believe anything that you presented because we did these experiments back in 1977, and here we are. This is 2005, nearly 30 years later." And I go, "Well, look, we have techniques and instrumentation and analytics today that you guys didn't have back in the late 70s. So we understand things better today than we did 25, 30 years ago." And so, he rolled the dice and took a bet on me and offered me a faculty position. And, we ended up kind of validating everything that I'd presented and, ended up changing the field. And so, then I started filing patents at the University of Texas. The patents started being issued, and, then became an entrepreneur and started companies and, productized the discoveries and, led these discoveries into actual products. And we're working on drug therapies now. So, those guys had a huge impact on my career, and it was really motivating and inspiring because what I learned specifically from Lou Ignarro was these really important observations that you make and how you take those and interpret the data from those observations and then use that to develop the next experiment, to change the way we think and to see what others have seen and to think what no one else has thought. But they inspired me, they motivated me, and, unfortunately, Bob Furchgott and Fred Murad passed, and Lou Ignarro is, the only remaining living Nobel Prize winner for the discovery of nitric oxide. And, I just spoke to Lou earlier this week, and, he was a good friend and good colleague and is very supportive. And I think that's one of the endearing qualities of Dr. Ignarro is he really, really supports young people and, the promotion in the ranks and, to keep advancing the field that he started.
What was the year of their Nobel Prize?
1998. The first
98,
discoveries were in 1977 by Fred Murad, and in 1980, Bob Furchgott published his paper. And then, 1987, Lou Ignarro discovered that this is nitric oxide. So a short 11 years later, after Lou published his seminal paper, that a Nobel Prize was awarded. And that's a very quick awarding of a Nobel Prize from the time of discovery. Usually this has to stand the test of time, and it's, sometimes 20, 30 years after you make the discovery that a Nobel Prize is awarded. But, Lou got this, a short 11 years later.
It sounds like you and I have some parallels because I've been working with a molecule. It happened to be discovered at Rice University in 1985. They won the Nobel Prize in 96. We started manufacturing it in 91. So you've just ended up in the right space with this kind of Nobel Prize and have been there from the beginning, same as me. And I think, correct me if I'm wrong, endothelium-derived relaxing factor was a thing that they called it. And then correct me if I'm wrong, because I didn't get a chance to dig into this, that the Nobel Prize was when they identified what that actually was. Is that correct?
No, that's correct. So Bob Furchgott, again, a very humble man and really just an incredible pharmacologist and vascular biologist. But he made, this discovery that the endothelial cells, these are the cells that line all blood vessels throughout the body, produced a substance that causes blood vessels to relax. And these were, the typical vascular experiments where you hang blood vessels between two force transducers and you can add substance to them. And if they constrict, you see an increase in force. If they dilate, then you reduce the tension. And you can actually monitor this on a myograph. And he discovered that
I just want to paint this picture, right? So you're taking blood vessels out of whatever particular animal model, and then you're putting them on a tensometer, which goes back to your civil engineering background, right? And then you're adding fluids to see if it contracts or expands. Like that's a fascinating, tiny study.
No, look, and it's revolutionized vascular biology because it can tell us what's constricting blood vessels, what's dilating blood vessels, and you can actually see this in real time. So these are living tissues in an organ bath that you can, add different things to and see how it modulates vascular tone. And so what he figured out was that if his lab technician at the time wasn't very careful and he maintained the integrity of the endothelial cells. Then every time he added a certain agonist, it led to vasodilation. But if his lab technician was
So
sloppy,
vasodilation, which is the expansion of the diameter of the blood vessel.
That's right. So it increases the luminal diameter. So now it normalizes blood pressure and allows for more oxygen and blood flow to the downstream organs. But what he quickly realized was if he was in a hurry or he had too much coffee and he was shaking and he damaged the endothelium, then that same agonist would cause a vasoconstriction. So the challenge was, how can the same experiment one day lead to vasodilation and the next day the exact same experiment lead to vasoconstriction?
And this goes back to the little piece you were talking about, seeing the results and actually interpreting them, right? Like, oh, it's just garbage and throwing it away, I think is what most people would do, but it was reproducible and he noticed that there's this consistent pattern. That's very cool.
No, but it was the irreproducibility of the experiment that led him to think, what can be going on? How can we get exact opposite results adding the same agonist? And that was the beauty and the brilliance of Dr. Furchtgott. He goes, maybe it's the endothelium that we're damaging. So then he would intentionally denude the endothelium, and now you would get reproducible results. If you denuded the endothelium, you always got vasoconstriction. If you preserve the integrity.
When you say denude, what does that mean?
Intentionally remove the endothelial cells from the lining inside the blood vessels. So now there's no functional endothelium. So then what his interpretation from that 1980s Nature paper was that there's a factor, he didn't know what it was, but it was derived from the endothelium that caused vasorelaxation. And he called this endothelium-derived relaxing factor. So EDRF. And then that stimulated enormous interest in vascular biology and even in pharmacology, because people go, if we can identify what this is that dilates the blood vessels, this would be a miraculous molecule, because hypertension, high blood pressure, is when we lose the ability to dilate the blood vessels. So blood vessels become thin, constricted, and same volume of blood in smaller pipes, pressure goes up. So if you can recognize, identify, and harness this endothelium-derived relaxing factor, it would change the world in terms of cardiology and vascular biology. So it took 7 years, from 1980 to 1987, to figure out unequivocally, and this was by Lou Ignarro and Salvador Moncada, that EDRF, described by Bob Furchtgott in 1980, is actually nitric oxide gas. And that's the endothelium-derived relaxing factor.
So real quick, how do they figure this out? Are they have gas meters in here? They're like, this is the fun stuff.
Yeah, no, and again, it's the brilliance of Lou Ignarro. Again, such a simple experiment, and this goes by using spectrophotometry, right? So it was known that if you oxidize the heme iron of hemoglobin, and you get this what's called a sorbet shift, that it shifts the spectrum of this molecule, because it oxidizes the heme iron of hemoglobin and it changes the spectral shift. So he basically exposed red blood cells, hemoglobin, to activated endothelial cells that produce this EDRF, and then exposed the hemoglobin, the red blood cells, to authentic nitric oxide gas. And you got the exact same spectral shift. So there's data, and his interpretation of the data was that EDRF is nitric oxide because both lead to this spectral shift in the absorption of hemoglobin. And so that was EDRF is nitric oxide. A very simple experiment that probably took less than an hour to perform, won a Nobel Prize. But again, it's finding objective endpoints and measures that the scientific community would accept and agree that this is real, EDRF is nitric oxide, and the methods and materials that he used were valid, and it's reproducible. And so there you go. So now we've identified nitric oxide is a thing that vasodilates, right? So it increases the diameter, and it makes perfect sense. You increase the diameter, it flows. Isn't that similar, like Viagra does this, Cialis does this? Are there a whole class of drugs that actually also do this? Yes. So the PD5 inhibitors, like the Viagra and the Cialis, don't affect nitric oxide production. I think that's a big misconception in medicine, even by cardiologists and urologists who prescribe these drugs. Those drugs do not affect nitric oxide. They work downstream of nitric oxide. So nitric oxide, when it's produced, it binds to an enzyme called guanylyl cyclase. and this gets into the complex biochemistry, but bear with me, but then this enzyme produces a second messenger called cyclic GMP. And then the second messenger that's produced as a result of nitric oxide production is what leads to calcium mobilization and smooth muscle relaxation, right? And so it's the PD5 inhibitors, the Viagras, that prevent the breakdown of the second messenger, cyclic GMP, because there's enzyme called phosphodiesterase enzymes that degrade cyclic GMP. And so if you degrade it, then you lose the vasodilatory effects and you lose erections and your blood pressure goes up. So these drugs are dependent upon nitric oxide production. And today we know that 50% of the men that are prescribed Viagra or Cialis don't respond with better erections. And it's because their body's not making enough nitric oxide to activate this second messenger system. So PD5 inhibitors are important drugs. They're very effective drugs. But understanding the mechanism of how they work, if we go upstream and improve nitric oxide production, now you can make non-responders responsive to that therapy, or no need for therapy because we're actually going above this mechanism and this checkpoint. If we can restore nitric oxide production, you can improve erections normally, normalize blood pressure without drug therapy. And there are other classes of vasodilators that are, sodium nitroprusside releases nitric oxide only used in hypertensive crisis. Organic nitrates like nitroglycerin have a nitric oxide mechanism of action. There are other vasoactive nitric oxide drugs. But what we've tried to focus on is how do we restore normal physiology without employing drug therapy or without having to employ drug therapy.
Well, I like the point. I mean, certainly in the biohacking world, longevity world, there's talk of, Viagra or Cialis taking a small amount every day for vasodilation being a smart thing. But what you're saying is that those are actually interacting downstream from nitric oxide. And if you've got nitric oxide problems, then those actually aren't even going to be as effective, if effective at all.
No, that's exactly right. And look, you have to look at the data. What I like to do and how I've thought for the past 30 years is let's take important clinical observations that are indisputable in the medical literature and then work backwards and figure out, okay, why do we observe this clinically? And once we understand the mechanism of action, we can make everything work better, right? And so if you look at the data, people that have used low-dose Cialis or Viagra have lower incidence of Alzheimer's. It reduces blood pressure and pulmonary hypertension. They were more resistant to COVID infection during COVID. So these are important clinical observations that we understand why they lead to these important clinical outcomes. And once we understand that, we can make everything better. And that's what I've been focused on is how do we restore the natural production of nitric oxide? Because if you do that, you can overcome Alzheimer's, you can overcome respiratory viral infections, bacterial infections, you can maintain normal erections, maintain normal blood pressure, metabolic activity. All of this is what nitric oxide does. So if we go upstream and get to the root of the problem, which is endothelial dysfunction, insufficient nitric oxide production, then everything downstream works as intended. And it's like what I say is nitric oxide is that first domino. Once you knock over that first domino, you've got a cascade of events. But if you don't affect that first domino, which is correcting nitric oxide insufficiency, nothing else downstream matters because you don't have the signal.
So I recently got a CT scan for like a clearly arterial blockage assessment right before I went in, right? So this uses an iodine dye. And right before I went in, they stuck something under my tongue. And I think they said nitric oxide. Do you know what that is? What that probably is?
It was probably, if it's a sublingual, it's nitroglycerin or isosorbide dinitrate. So it's what we call an organic nitrate that's metabolized into nitric oxide. So what they can see is how well vasoreactive your blood vessels are. Because these are endothelium-independent sources of nitric oxide that can dilate the blood vessels and basically get a clear picture. Or in many times in the cath lab, they'll use adenosine, which is an endothelium-independent vasodilator. But there's different mechanisms to dilate the blood vessel. Some people will use organic nitrates, other people use adenosine.
My understanding is that nitric oxide is very transient, right? So it's one of the reasons that the way he identified that it was nitric oxide was so brilliant is because there really is no way to get a gas spectrometer in there or take samples. Talk a little bit about how kind of transient it is.
Yeah, so the physical chemistry of nitric oxide, once it's produced, it's gone in less than a second. right? So it's a gas, it diffuses in 3-dimension, activates these second messenger systems, binds to proteins, affects their structure and function, and regulates and modulates a lot of cell signaling events. And so you can't, I mean, those are the physical properties of nitric oxide. And so it's the second-to-second production of nitric oxide that allows for this signal transduction to vasodilate the coronary arteries if you start to exercise, to dilate the blood vessels of the sex organs if you're about to have sex. Or you can deliver that nitric oxide and then again start this domino effect and start these second messenger systems. And so understanding its mechanism of production and signaling and activation, then that allowed me and my research team to figure out, okay, how do we, if your body can't make nitric oxide, then we got to give it for you. And so it was kind of like hormone replacement therapy, right? If men can't make testosterone, we give you testosterone. But you get this spike, this peak, and then it comes down. But similar to testosterone, once you get this peak, it starts all these other signaling cascades, turns on certain genes, turns off certain genes, starts this whole signaling cascade. Same thing with nitric oxide. If we give a bolus of nitric oxide in the oral cavity through this orally disintegrating tablet, we get this peak in plasma concentrations. It activates the second messenger system, turns genes on, turns genes off, modulates inflammation, induces mitochondrial biogenesis. So we just have to give it back. If your body can't make it, we got to do it for you. But more importantly, we understand the mechanism that we can restore the body's ability to make nitric oxide on its own. And that should be the goal.
So do we have any indication, like all things aging related, the curve goes down, starting at about 30. Do we have any idea why, what the mechanism is going on there that's causing the nitric oxide to down? Is it the change in hormones? Is it, what kind of things are you looking at to address so that we can continue to produce nitric oxide naturally?
It's called living in America. It's a Western lifestyle. Look, it's all the known cardiovascular risk factors. It's smoking. It's a poor diet, really a high carbohydrate, high glycemic index diet. It's sedentary lifestyle. It's what Americans do, everything we do. And it's the use of drug therapy. It's the use of antiseptic mouthwash. It's the use of fluoride in drinking water and toothpaste. So what we've learned is all of these things disrupt nitric oxide production. So although we see this age-related decline in nitric oxide production, we look at population-based studies, we now know that we can prevent this age-related decline, right? So I'm 51, but I've got the vascular age of a 36-year-old, and so I'm trying to kind of work backwards there. So, and what does that mean? Well, you can't eat sugar. You can't eat things that contain sugar, that glycate enzymes and stick to proteins and makes everything sticky. We have to move. We have to exercise. Exercise stimulates nitric oxide production. We have to optimize our hormones and prevent this age-related decline in hormone production, whether it's thyroid hormone, testosterone, estrogen, all these hormones, because hormones, particularly the sex hormones, activate and stimulate nitric oxide production. Then avoidance of things like antiseptic mouthwash that kills the oral microbiome, getting rid of fluoride, getting off drugs like cholesterol-lowering medications and antacids and all those things that inhibit nitric oxide production.
All of these other kind of upstream things affect nitric oxide production. One of the solutions is, like, as you described, a bolus of nitric oxide, but it is a fairly transient gas. So how does that end up manifesting in terms of, you'd really like to increase nitric oxide production throughout the day? How does that kind of bolus kind of play out?
Well, this goes back probably 25 years ago when we were looking at the effects of inhaled nitric oxide. Because inhaled nitric oxide, we deliver it through a nasal cannula in an inpatient setting. It's been used to treat premature babies with pulmonary hypertension since the late 80s. And so at that time, it was thought that inhaled nitric oxide would only have local effects, local pulmonary effects. It wouldn't affect systemic circulation. And that was the premise that all these studies were approved on. The FDA approved this because it would only have local pulmonary effects and not systemic effects. So the good news is nitric oxide dilates the pulmonary arteries, mitigates the effects of pulmonary hypertension, and improves oxygenation and matches ventilation to perfusion, which is the problem in pulmonary hypertension, especially in neonates. But as we started investigating the blood profile of patients and animals getting inhaled nitric oxide, there were systemic effects. And so it was a dose-dependent effect. So for me, You don't want to lower systemic blood pressure, right? Because if you lower systemic blood pressure to an unsafe level, you lose perfusion pressure, you get syncope, you pass out, and you can have end organ failure.
So, and I've heard you explain this before. So basically, if you don't have enough, if your blood vessels are so big that your heart pumping through drops the pressure, you need a certain amount of pressure to pump blood against gravity, so it actually starts not getting to your brain. I think that's an important
exactly
thing
right
to describe.
Yeah, so you have to maintain some perfusion pressure. So there has to be a pressure gradient from the heart to pump blood here to the head, which is working against gravity. Anything below the heart, gravity is going to do it, but it's the venous return that we worry about sometimes. But yeah, so if your blood vessels are dilated and you can't maintain enough pressure, then you can't perfuse the brain, you get lightheaded, you pass out, and it can be deadly. So you have to be careful with that. It's called hypotension. And so, yeah, if you give too much nitric oxide, it leads to vasodilation, systemic dilation, then you lose perfusion pressure. So it's a dose-dependent effect. So how do we deliver the right amount of nitric oxide over the right period of time that we could normalize blood pressure in hypertensive patients, but wouldn't lower blood pressure in people with normal or low blood pressure? And then what is that dose that could also start to transduce the signal transduction to improve glucose uptake, to improve insulin sensitivity, to downregulate the adhesion molecules and reverse inflammation, and to change the M2 macrophages to M1 macrophages and overcome immune dysfunction? And so that's what we've been focused on, is the amount of nitric oxide, the dose of nitric oxide over a certain period of time that would achieve all those results without any safety concerns. And that's really the riddle we've solved.
Hey, super quick break from the podcast. Hopefully you're loving it. This is a way you can support the podcast and take advantage of a great offer. We're offering 50% off of one of our MCT bottles. MCT is an amazing oil. Add the ESS60 molecule to it. It's even more amazing. All you got to do is leave a review on iTunes, send us a notification that you've left that review. We'll get you a coupon code that'll get you 50% off of our MCT oil and free shipping. Back to the podcast.
I heard in one interview, actually on Diary of a CEO, that you talked about the nitric oxide being this longevity molecule, that it just ticks all sorts of longevity boxes. Can you walk us through that?
Yeah, this whole field of longevity, I mean, you're in it just as I am, the biohacking and how do we live a longer, healthier life free of disease. And there's some adaptive effects. There's some genes we can turn on. There's some bad genes we can turn off. And so what I looked at when I started on this probably 15, 17 years ago, how do we measure longevity, right? So you can look at the length of telomeres. These are the ends of the chromosomes. You can look at histone methylation modification of our DNA. You can look at mitochondrial function, the number of mitochondria per cells. And then you can look at the number of stem cells in circulation. So those were, at the time, the objective measures of longevity. Longer telomeres, longer lifespan. And we knew that nitric oxide activated the enzyme telomerase that prevented telomere shortening. We knew that nitric oxide activated mitochondrial biogenesis. So if you made nitric oxide, the mitochondria that you had in the cell were more numerous, and then more mitochondria were generating more energy more efficiently with less oxygen. And then we knew that nitric oxide was actually the molecule that told our own stem cells to mobilize and differentiate. So nitric oxide is the longevity molecule, because without nitric oxide, we get shorter telomeres, less mitochondria, and less stem cells in circulation. So we don't repair and heal. We have these senescent cells, these zombie cells that stick around, and we have shorter lifespan. So if we can focus on restoring the production of nitric oxide, we can extend lifespan, health span, improve mitochondrial biogenesis, and lead to better healing, better cellular turnover. And we're regenerative by nature. We just need to give the body the signal that it needs to regenerate, mobilize our own stem cells, and that's what nitric oxide is, and that's what it does.
So there are different products on the market that kind of focus on telomeres, that focus on mitochondria, that focus on stem cell. Have you looked at those, and are they ultimately maybe just increasing nitric oxide, and that's the thing that they were measuring as they were checking the different formulas?
Yeah, so a lot of these products, so-called natural products in the dietary supplement space, most of them are plant-based, plant-derived compounds. And so, if you take those and you understand the mechanism of how these are working and how they're inducing the signaling, most of the time it's downstream of nitric oxide, right? And so you've got these, these stem cell mobilization products in the dietary supplement that are plant-based, And we've published on this for the past 20 years that some plant-based compounds can be metabolized into nitric oxide, and it just leads to an increase in nitric oxide signal, and that's what's responsible for the mobilization of stem cells. The problem is when you start trying to culture these and then dry these plants into a powder that you can put into a capsule, many times the drying process, and we've experienced this with beets, for example, you lose all the nitric oxide activity through the drying process. And because there's so much variability in the processing in the fields or the seas where these plants and products are harvested, you lose it, and there's so much variability. So there's never a standardization of that on these products. So, sometimes, people give me products all the time to take, and, do they work? I mean, there's really not an objective measure that I've been able to see. But, for me, if it's no risk and some benefit, then I'll roll the dice and take it. But to answer your question, what we know from the published science literature, and based on what we know about mechanism of action, all you need is nitric oxide. If you want to induce mitochondrial biogenesis, improve nitric oxide production. You want to activate telomerase enzyme, improve nitric oxide production. You want to mobilize stem cells, take nitric oxide. And then again, that's the first domino. The domino effect takes into effect, and you get all the effects you want to see in terms of longevity and biohack.
And you've mentioned already, like, exercise will increase nitric oxide production. Beets. So as I was kind of preparing for this interview, talk a little bit about beets. Like, there's products out there that the beets are dead, and so they're not really of any value, which is kind of what you were just talking about. Talk about how do beets come up here in this conversation?
Yeah, beets. And here's the problem in this industry. For-profit companies take some published headlines in the scientific literature and then run with it, right? And so beets, this science goes back probably to the early 80s and mid 80s, where inorganic nitrate that's found in green leafy vegetables can be metabolized by bacteria that live in and on the body into nitric oxide. And so in the 2012 Olympic Games, there were quite a few interesting studies coming out in terms of athletic performance. This was done in London and the Karolinska Institute in Stockholm, where these scientists were taking standardized nitrate in beetroot juice, giving it to athletes, and you could improve exercise performance. So this was all based on a nitric oxide mediated effect. And they standardized the beetroot for a specific amount of nitrate. But, they required these people not to use antiseptic mouthwash, complete elimination of fluoride in their drinking water, so that you could have the right oral bacteria to metabolize the nitrate in the beetroot juice to produce nitric oxide and see the performance-enhancing effects. So then it was realized in the 2012 London Olympic Games that all of these athletes were drinking liters and liters of beetroot juice, causing a lot of gastric discomfort. But I think the UK Olympic team, that Olympic won more medals than any time in the history of the Olympics. So that created this frenzy of, beetroot. So all these companies started manufacturing beetroot and really going on the coattails of this really good science. But then I started testing all of these beet products on the market and found that there's really no detectable nitrate and nitrite. Companies were taking the cheapest beetroot they could find, putting it in a powder, calling it beetroot juice, and then calling it a nitric oxide product.
Wow.
And it's disingenuous. It can move the field backwards. And now you've got all these companies out there selling beets in different form factors, calling it nitric oxide. And I've tested these, and it provides no nitric oxide benefit. And, companies have sued me for revealing this, and it's disheartening, but I think we have an obligation. I feel I have an obligation, responsibility to maintain the integrity of the science and the integrity of the field. Because here's what happens. You see these beet products advertised on TV, then people email me and go, Nathan, I took this beet product that was advertised on TV and it didn't do anything for me. In fact, sometimes my blood pressure got worse, made my blood pressure go up. So nitric oxide must not work for me. And I go, no, wait. That's a complete misinterpretation. Nitric oxide always works, right? The problem you encountered was that the company selling you a beetroot product doesn't have nitric oxide in that beetroot product. So of course your blood pressure didn't come down. Of course you didn't see a benefit. And that's the Wild West of the dietary supplement industry, was all these companies can say the same thing and you don't have to have real science behind it. And that's the problem that I hope to solve, was understand the science, understand the products that produce nitric oxide, understand companies that are built on real science with real scientists that provide products that you can count on and that have objective measures of a nitric oxide analyzer that can detect, quantify, and verify that these products produce nitric oxide, and all these others are just noise. And, once we start to educate and inform consumers, and these consumers no longer buy those products, these companies go away because they can't survive if they can't dupe their consumers anymore into buying these products that are advertised as nitric oxide but provide no nitric oxide benefit.
You are literally describing, whatever my nightmare in kind of my industry, which is
happens in every industry.
And we know it's in every supplement industry, right? Like I always kind of say the politically correct way to describe the supplement industry is challenged. Like that's politically correct and gives a hint of it. And so, yeah, we're out here fighting the good fight, trying to make sure and that's my worst nightmare. Somebody's like, oh, I tried that stuff. It didn't work. You didn't try that stuff. You actually tried something that didn't have a concentration or in some of your cases, nitric oxide. No, not even producing any nitric oxide. Is there something special about beets, or did they just get a lot of press at the Olympics? Like, are there other kind of plant-based sources of nitric oxide that might even be better than beets?
Yeah, I think beets are what stuck.
And by the way, it's beet roots, right? It's not the actual beet.
Yeah, beets I think are what stuck in the consumers. But to me, beets, and it's not to me, this is real data. It's the third least liked vegetable in the world. Right? and it's messy. So why would you use beets as a delivery for this? Because it's really not that, there are things much better. Kale, arugula, the darker the green leafy vegetable, the better. The beet root actually the leaves typically have more nitrate and nitrite than the root, no matter what vegetable it is. But beet somehow just stuck. And so that's what companies and what consumers drew to. But again, a lot of these products, when we were doing clinical trials, I couldn't even stomach drinking the beetroot juice. And a lot of the participants in clinical trials, the attrition rate is so high because they don't like the taste of it and causes enormous gastric discomfort. Then the other thing it does is it turns your poop and your urine red and pink, and people think they have urinary bleeds or bladder cancer or, colon cancer and bleeds. And it's just a result of drinking the beetroot juice. But no, and to answer your question, it's highly variable. And we published this in 2015 where we took the same vegetables from 5 different cities across the U.S. and just measured the nitrate content and found that there's a 50-fold difference from celery grown in Dallas versus Los Angeles, New York, Chicago, and Raleigh. So depending upon the soil conditions, the growing season, amount of sunlight, time of harvest, all this affects the nitrate content. So you really can't rely on beetroot products to provide a standardized amount of a supplement form that can produce nitric oxide. And you can't rely on eating celery from the grocery store, kale or arugula to get a standardized amount of nitrate. And that's what we tried to do, was take the guesswork out of it. Take our products that we give you the same amount of nitric oxide in every single person, regardless of oral bacteria, regardless of medication, regardless of endothelial function. If your body can't make it, we do it for you at a dose that's safe and effective.
So you mentioned arugula, it's a little bitter. Kale, I think, is a little bit bitter. Is the bitterness kind of tied to nitrite? What's the difference also go over the difference between nitrite and nitrate?
Yeah, no, I don't think the bitterness is, there's so many plant compounds in green leafy vegetables that provide that taste profile. But no, usually, typically nitrite and nitrate are tasteless. They're salts in a solid dose form. So you can take these as sodium or potassium salts. Nitrate is NO3 minus. It's a very stable molecule. It's inert in humans. Humans don't have an enzyme to metabolize nitrate, and that's why we're dependent upon the bacteria. Nitrite is bioactive, but it's much more potent, so you have to be careful because nitrite can cause methemoglobinemia and cause an unsafe drop in blood pressure. So you have to be careful with that. So most of these products that are selling you nitrate in the form of a capsule or beet products, it's dependent upon the oral bacteria. So if you don't have the right oral bacteria, you sweat out the nitrate, you pee out the nitrate, and you poop out the nitrate. It goes through the body completely unchanged. It's inert. And with 2 out of 3 Americans using mouthwash and most people using fluorinated toothpaste and 73% of the municipalities in the U.S. put fluoride in their drinking water, 80, 90% of the general population will not get any benefit, a nitric oxide benefit from vegetables or a nitrate-based product because they don't have the right oral bacteria.
And so it starts in the oral microbiome. Is there something about the oral microbiome that doesn't get to the gut? And so if it gets past oral without any sort of that bacteria clamming onto it, it's rendered basically ineffective?
Well, you have to understand the mechanism of uptake and activation of that. So when we masticate the food, that's breaking down the kind of the matrix of whether it's vegetables or meat protein, and then we swallow it. And then it's absorbed, the nitrate is absorbed in the gut, the proximal gut, the duodenum, and then it's concentrated in our salivary glands. And this takes about 90 minutes. From the time you eat beets or spinach or celery or arugula, it takes 90 minutes for your saliva to be concentrated in nitrate. So now we're getting slow secretion of nitrate in our saliva over the next 6, 8, 10 hours. And they're nitrate-reducing bacteria that live on the crypts of the tongue that now perform this 2-electron reduction of nitrate to nitrite. Now our saliva is enriched in nitrite, and I developed a test strip for this back in 2010 that quantifies salivary nitrite. Now when we swallow our saliva, as long as we have stomach acid production, we're getting a burst of nitric oxide gas in the lumen of the stomach. So that's how this works. So it's not only dependent upon the oral bacteria, it's dependent upon, stomach acid production as well. And 100 million prescriptions written for antacids every year. At least 2/3 or half of the population takes over-the-counter antacids, completely shutting down nitric oxide production and leading to increased risk of heart attack, stroke, and Alzheimer's. So it's a very complex pathway. So you can't just take these products naively and expect to make nitric oxide. In fact, most people don't because they lack the mechanism.
Yeah, well, if you say 2 out of 3 are using mouthwashes that are killing the bacteria, do we know which particular bacteria it is? Is there something that as a probiotic, that we could take to support our microbiome, our mouth microbiome to facilitate this process?
Yeah, we've identified the bacteria. We and others have done a full metagenomic analysis, and we published this in the scientific literature. So we understand the bacteria that are necessary and sufficient for adequate nitric oxide production. And we know that if you don't have these bacteria, you have higher blood pressure. People who have these bacteria in higher numbers typically have normal blood pressure. So, I filed a number of patents on these, but to answer your question, there's not any commercially available oral prebiotics or probiotics that we've seen move the needle on the oral microbiome. So the oral microbiome is different than the gut microbiome. But obviously, we swallow our saliva, we're swallowing these bacteria. They can colonize at different parts of the gut based on the different metabolic activities and requirements of that particular part of the gastrointestinal system. But we figured out, and it may be very simple, right? Just stop doing things that destroy the microbiome, do things that support, that increase the diversity. And what we find is diversity equals better nitric oxide production. So we've made now a nitric oxide friendly toothpaste. We've removed all the things that destroy the microbiome. We're putting things in there that we've shown to improve the diversity of the microbiome, improve nitric oxide production. And we're seeing actually a normalization of blood pressure in people that have resistant hypertension. Now think about this. Resistant hypertension is a huge problem. 50% of the people that are prescribed blood pressure medicine don't respond with better blood pressure. And what we focused on is maybe the hypertension, the high blood pressure is due to oral dysbiosis. So if we can restore the normal flora, restore nitric oxide production, dilate blood vessels, normalize blood pressure, simply by focusing on the oral microbiome, think about the profound impact that has on public health. Because high blood pressure is the number one driver for the number one killer of men and women worldwide, which is cardiovascular disease. So simply switching to our toothpaste, using a nitric oxide friendly mouth rinse, which we're about to launch, we can normalize blood pressure and address the number one driver of cardiovascular disease. That's huge. And we get people off medication. Think about getting people, for the first time in the history of Western medicine, we can have a conversation of how do we get you off prescription medication? Because if we can normalize your blood pressure through natural means, there's no need for blood pressure lowering medication.
No, that's fantastic. All right, so you have I have ideas of many directions to take this conversation. I want to be mindful of time. So you've got a toothpaste. And you just mentioned briefly another product that's about to come out. What was that?
Well, we think toothpaste, we've had products on the market for a number of years, but toothpaste was a big deal for me because I've intentionally avoided fluorinated toothpaste for probably 15 or 20 years once we got into the science. But there were things in it that I still didn't like, and there were things missing in it that were necessary for optimizing the oral microbiome. So I spent about 5 years working through this project, trying to figure out how do we develop a non-fluorinated toothpaste that can remineralize the teeth, support the oral microbiome instead of destroy it. And we launched that several months ago, but it's called Cardio Smile. But it's a hydroxyapatite-based toothpaste. It normalizes the salivary pH, improves the oral microbiome, improves nitric oxide production, and it's an incredible product. But because 2 out of 3 Americans want to use mouthwash for a clean breath, we felt, let's give them a healthy alternative because antiseptic mouthwash is really bad. Mm-hmm. So when you see these commercials, well, this kills 99.99% of the bacteria, that's a true statement. But I wouldn't be advertising that if I were these companies. It's a bad idea, right? Nobody would take an antibiotic every day to kill 99% of their oral bacteria or the gut bacteria because we know it causes systemic disease. And these mouthwashes are causing systemic disease. So we're launching this, it's called Breath of Life. We'll launch it probably in the next couple of months. But it's a mouthwash, again, that kills the pathogenic bacteria, the odor-causing bacteria, improves the diversity of the non-pathogenic commensal bacteria, optimizes salivary pH, and leads to an enhancement of nitric oxide production. So we think, we don't think, we know that a lot of nitric oxide production starts in the mouth. So if we can give people a good toothpaste, a healthy mouth rinse, normalize nitric oxide production here, we can optimize their systemic health. And that's this oral systemic link. Good oral hygiene, good systemic health. Poor oral hygiene, poor systemic health.
Very, very cool. Have you connected with Dr. Dom, the biological dentist out of Germany?
I did. Yeah, Dom's a great guy. He's doing great work and really educating the public on the dangers of root canal, metals, and oral dysbiosis. So yeah, Dom and I are good friends. We collaborate a lot. He's a really good guy.
Yeah, I remember when I interviewed him, he didn't really have a toothpaste to recommend, and I think yours has come out since then. So hopefully he's recommending yours. And also, I mean, I'm sure yours is available in the U.S. Maybe it's available worldwide. All right, so we've got the toothpaste, Cardio Smile. We've got Breath of Life coming soon. If you insist on having some sort of mouthwash, which in general you're like you don't need it, but if you insist on it, now you've got a viable type. I don't think that's the core business, right? Toothpaste just came out. What is the nitric oxide products that you have, and how do they function? Do they kind of extend nitric oxide production throughout the day? What does that look like?
Well, again, it was based on my discoveries early on that if your body can't make nitric oxide, then we got to do it for you. And we do this through what's called an orally disintegrating tablet. So I made really the first and only solid dose form of nitric oxide gas. And so this is a nitric oxide releasing tablet. You put it in your mouth, and I designed it to have a resident time of about 5 to 6 minutes. So this lozenge, this matrix slowly falls apart. And then during this dissolution rate, we're releasing 20 to 30 parts per million nitric oxide gas. Right? So if your body can't make nitric oxide, I'm doing it for you. But because it resides in the mouth, it's killing the pathogenic bacterium. It's improving these nitrate-producing bacterium, restoring the normal microbiome. And we understand the enzyme nitric oxide synthase to where we can restore the function of the enzyme in the endothelial cells. So if your body can't make nitric oxide, this product does it for you. But we're improving the body's ability to make nitric oxide on its own through the oral pathway and through the endothelium, the release of endothelium-derived relaxing factor, which is where this conversation started. And then we make beet. People are looking for beets, so I made a fermented beet product, beets. But again, we standardize it. We take out the beet pulp, the beet taste, the oxalates, and we put mitochondrial ATP in here and electrolytes. So you put this in 2 to 3 ounces of water, take it as a shot. Incredible energy product in a pre-workout. And then we make a topical nitric oxide, a dual chamber topical for skincare and beauty. You mix these 2 chambers together, apply it to the face. It produces nitric oxide. You can see your skin turn pink, mobilize the stem cells, fine lines and wrinkles go away. improves collagen deposition, six published clinical trials on that product. It's amazing. And we're developing this into drug therapy. Now, drug therapy for heart disease, Alzheimer's, and we're making a topical drug similar to this for non-healing wounds and diabetic ulcers. And it'll be a game changer.
And the lozenges, are those something that you're taking, 2 times a day, 3 times a day? What does that look like?
I mean, everybody's different. For me personally, I wake up in the morning and I take the shot of the Beets. Because when I wake up, I brush my teeth, I take the Beets, and then I work out. So that gets me through the workout in the mornings. And then I take the lozenges in the afternoon. But for most people, 1 lozenge in the morning, 1 in the afternoon is sufficient. I like the combination of the Beets and the lozenge, but you can kind of custom tailor what works for you.
Very cool. Now I've got my wrap-up questions. Dr. Bryan, what's new in your industry that you're excited about?
I'm extremely excited about the future of nitric oxide-based product technology. We've had products on the market in the supplement space, the skincare and oral for a number of years now, but I think the future is in drug therapy. We've got drugs that we're developing for heart disease, for Alzheimer's, and topical drugs for diabetic ulcers. And I think, I know that nitric oxide is going to change the landscape of healthcare and how we treat patients for the next 100 years.
Excellent. Dr. Bryan, what is your favorite health-related book and why?
My favorite health-related book is a book by Jerry Tennant called Healing is Voltage. We're electrical beings and we have to, maintain cellular voltage and transmembrane potential. And Jerry Tennant's been a pioneer in energy medicine. He's an ophthalmologist by training, but cured himself using voltage. So Healing is Voltage has been a revolutionary book for me in understanding how do we integrate energy medicine into human biology and physiology.
Excellent. Dr. Bryan, what was your first biohack and why do you still do it or why did you stop doing it?
I would say my first biohack, once I got introduced to what biohacking was intermittent fasting. And I still do it because it really changed, my entire metabolism and I think my body composition. And when you look at the scientific and the clinical data on intermittent fasting and caloric restriction, it's really indisputable. So I recommend everybody do it. It changes your metabolism. It goes back to caveman days, periods of scarcity, periods of plentifulness. And so that's I still do it every day, an 18-hour fast.
Do you do anything longer than 18 hours? Have you ever done 24 plus or 48?
About once a month, I will do a 24, 48. I've done a 72-hour water fast in the past, but usually once a month, I'll do a 24-hour, 36-hour fast. If I feel like my body's breaking down and I need to do a longer fast, then I'll do a 72-hour fast.
I also tend to do it after, if I have a weekend where I broke a lot of rules, I'm like, let me just, let me go until Tuesday.
Let's reset. Yeah, I agree.
Dr. Bryan, what supplements do you take every day?
I wake up every morning and I take my nitric oxide product, typically my Beets that I start 2 to 3 ounces of water. I take a chlorella and a spirulina product, as binders, and they're really nutrient-dense materials. I don't eat a lot of organ meat, so I eat a capsule of wild bison organ meat and salmon roe as my fish oils. And really, I used to take a handful of supplements, and then I realized probably a lot of this my body didn't need it. I started doing nutrient analysis, figured out what my body needs. And so those are my go-to, the chlorella, the spirulina, the organ meat, and then my nitric oxide. And magnesium at night before I go to bed.
Excellent. Dr. Bryan, what is your favorite longevity and health piece of equipment and why?
I come to realize how important water is and how toxic municipal water is. So I have a water purification system in my home, but also in my pool. And so the pool is a chlorine-free, chemical-free pool. It oxygenates, ozonates the pool, and then uses UV light. And we've seen this during COVID. I could put people in my pool and raise their blood oxygen saturation from 76 to 98 within 5 to 10 minutes. So water is extremely important because it's not just the water we're drinking, it's the water we're cooking in, bathing in. And so I think that's been probably the biggest piece of equipment or most impactful piece of equipment for biohacking.
Awesome. I'll just share with you, I got a chance to visit. There's a company called Bimini, and they
Oh yeah, I know those guys. Yeah.
Okay, so I'm about to borrow borrow one of their things. I got to go visit their facility, took a camera, so we've got some content that's coming out there. I'm pretty excited about that technology.
Yeah, no, they're encouraging me. I'm probably going to be on their board. They've been reaching out to me, and I just haven't had the bandwidth to do it. But I love their technology. I have it at home, and they're good people.
Is that something that you use once a week, daily? I mean, taking a bath is a pain.
Yeah, well, no, the shower system I has utilizes their technology, so it's an outdoor shower, actually it's in my garage, but it infuses minerals and it puts voltage into the water to where you can transdermally deliver the nutrients.
Is that
so
the
it's
same?
A little bit different than just the Bimini. The Bimini is kind of the core, but when we infuse nutrients, it's a different system.
So Bimini has a shower product? I didn't even have a conversation with them.
Now, part of their technology is utilized in this company called pH Prescriptions, yeah. But it's using the structured water, the ozone, the hydrogen, same thing they do in the tub.
Interesting. Very cool. All right, back to our questions. Dr. Bryan, what is your favorite movement or exercise hack and why?
For me, every day starts with 100 push-ups and 100 squats because, people have the excuse they don't have time to go to the gym. But when I started this probably more than maybe 2 years ago, it takes me less than 4 minutes. But that every morning when I wake up, I do 25 push-ups, 25 squats, and I do 4 sets of that. But it gets my blood going. It starts out my day, increases my heart rate. I actually start to sweat. But anybody can do that in less than 4 minutes. So you no longer have the excuse that you don't have time.
I love the concept of being able to put we're from Texas, a big old check mark next to I did some exercise today, and that's nice and simple. That's exactly right. Dr. Bryan, are there any hacks that are out there that you think are absolutely crazy or at the minimum need more research?
Yes, it's very simple. The use of methylene blue. I never understood this because we in the scientific community have used methylene blue for the past 40 years to intentionally inhibit nitric oxide production and nitric oxide signaling. So these people out there using methylene blue on a daily basis as a prophylactic is probably the worst idea you could ever do or come up with for biohacking. Anything that inhibits nitric oxide production and healing is going to accelerate chronic disease, is going to decrease your lifespan, decrease mitochondrial efficiency, and decrease the mobilization of stem cells. So methylene blue is a horrible idea, and I wouldn't recommend anybody do it.
Thank you. Dr. Bryan, what do you wish you knew or adopted earlier related to health and longevity?
The dangers of sugar and simple carbohydrate, because over the past 50 years, we've been kind of programmed to think that cholesterol and red meat and fats are bad for us and cause chronic disease, when the whole time it was sugar and simple carbohydrates. Once I started eliminating sugar and simple carbohydrates from my diet, it completely changed my metabolism, how I felt. And so if we would have known this early on and, looking back at my childhood, it was eating processed food, junk food, donuts, sodas. Fortunately, I recovered from that. But unfortunately, most people don't. We've got kids today that are 12, 15 years old, morbidly obese. And it's because they're sedentary and they're eating processed foods and a lot of sugar and carbohydrates. And we have to eliminate that.
Dr. Bryan, this is myth, must, or maybe. First one, lots of protein.
It's a must. Especially the older we get.
Animal protein is better.
I mean, maybe. I think, different people, plant-based protein seems to work if they have chronic disease. Animal protein works for some people. Specifically, personally, for me, I'm O positive blood type, and my body craves animal protein. And I do better on animal protein.
Cold plunge.
Again, I think that's a maybe. Me personally, I get a lot of benefit out of it. I think if you get congestive heart failure or cardiovascular disease or increased risk for cardiovascular disease, I don't think a cold plunge is something I would recommend.
Sauna.
Sauna is a must. There's so many benefits of sauna. Detoxification, especially infrared saunas, activate mitochondria. So sauna is a must.
Red light therapy.
Red light is a must. I think the best source of red light is the sun, early morning sunlight, 20, 30 minutes of sunlight as the sun's coming up is the best form of light therapy. But if you can't do that or don't want to do that, then red light therapy is a must.
Your favorite, methylene blue.
There's no such thing.
Next, intermittent fasting.
Intermittent fasting is a must. Everybody can benefit from that.
PEMF.
PMF, I think, is a maybe, because the science out there is good. It can activate endothelial nitric oxide production. But first, we must restore the function of the NOS enzyme so that the PMF can actually activate and stimulate nitric oxide production.
Peptides.
Peptides, I think, are a maybe. The science is still evolving on it. The mechanism of action of these different peptides and amino acid sequences, I think there's still a lot to be learned. But I think, there's some benefit from some peptides.
Stem cells.
Stem cells are an absolute must. We're regenerative by nature. We've got to mobilize our own stem cells to repair and replace cells that aren't working properly.
Extended fasting, so 24 plus hours.
Again, I think that's a maybe. For me, it's once a month. I think it's probably a must. But for most people, again, understanding their unique composition, their metabolic demands, their underlying disease risk and profile. But teetering on must, but certainly a maybe.
All right. The next is the Live Beyond the Norms challenge. Dr. Bryan, what are one or two things you would challenge the Live Beyond the Norms audience to do this week?
Wake up every morning and figure out how you can make the world a better place or the people around you happier and help them and live with a servant's heart. And, the second would do intermittent fasting. See how your body responds to an 18 or 24-hour fast. And I think what most people realize is that they feel better, their body can, regenerate and, to completely change their metabolism.
Excellent. Dr. Bryan, if you could have a magic wand in Robert F. Kennedy's position, what would you change?
I would certainly address the things that are bad for us in the environment and in our food supply. Secretary of Health and Human Services, that encompasses a lot of agencies. But I think he's on the right track, removing a lot of toxic, carcinogenic food dyes, trying to implement programs where the food that we grow and eat in America is replete in nutrients, because now we know since the 1940s, there's been a 78% depletion of basic macro and micronutrients in the food grown in America. So if we can eliminate the things that are toxic to us and replete the missing nutrients in the human body, our health will be better for it.
All right. Do you have a target age that you want to live to?
I don't. I haven't given it much thought. My objective every day is when I get up is how do I be better than yesterday? And each day I wake up on a daily basis with a servant's heart, gratitude, and I strategize my day and figure out how am I going to execute my plan to be better than I was yesterday. I don't have any motivations to live to be 150 or 180 or 200 years old if I don't have a quality of life. I want to live the best life and die as young as I can. Die as old as I can, feeling young.
If you have that quality of life, what age pops to your mind? What's the first number that pops to your mind?
I think we're going to see people live beyond 150, perhaps even 200. But again, I think if I'm not able to get up and exercise and enjoy life and live pain-free, disease-free, then I have no ambition to live like that, because I'm, as a Christian, I think we have a very short time here on life, and it's the life everlasting that I look forward to.
So I guess you bring up a good point of how I can change, because I get a lot of people like, as long as I'm being productive or whatever. So how long do you think you're going to live a productive life? And then, what is that? And I know I'm pushing you, but what's the number?
Probably for me, it's 150. I'm 51 years old. I feel better today than I did when I was probably 30 or 32, because I think, at least for me, the older I get, I'm more in tune with my body now. And I know things that if I do that I'm exposed to, or foods that I eat that don't agree with me, I feel bad. So I avoid those. So now I try each day to fine tune and optimize my biology to where I feel good every day when I wake up. I have a productive day. I sleep well at night. That prepares me for another productive day the following day. But yeah, I would expect that I could live to 150, another 100 years in me that are productive, to where I feel good, I want to live, and I wake up with a mission and something to do every day. I have a purpose. If we don't wake up with a purpose, I think, why are we living?
That's awesome. And then, and you've kind of touched on this, but how long do you think humans can live?
Looking back at, even the biblical days, Methuselah, there's hundreds of, people living more than hundreds of years old. I think, certainly technology's advanced. The world wasn't as toxic back then, 2,000 years ago or even longer. We live in a very toxic world. So, it's hard work staying healthy today in the world we live in because we're exposed to so many toxins. We're nutrient deficient. The food we eat doesn't have a lot of nutrients. So it may be harder today than it was hundreds of years ago because of just the toxic world we live in.
So you kind of mentioned 200. Is that a number you'd kind of throw out as the potential?
I don't think it's beyond the realm of possibility. I think we probably see people do that.
Very cool. What are 2 to 3 protocols, habits, mindsets, let's call them shortcuts to longevity, because everybody loves shortcuts, to longevity and a long health span that you would share?
If I had 3, number 1 is intermittent fasting and caloric restriction. I do an 18-hour fast every day, and it's really had a profound impact on my metabolism and kind of my physique and kind of body fat composition. The other is prayer and meditation. Again, waking up with a purpose and showing gratitude and living with purpose, living a purpose-filled life. And then the other is detox protocols. I sit in a sauna every day. I think we have to sweat. We're programmed now not to sweat. Nobody sweats. You can actually get your sweat glands lasered where you no longer sweat. That's how toxins build up. We detoxify through deep breathing, to urination, defecation, and sweating. And for me, it's that contrast therapy. It's going from a sauna to a cold plunge. I think those are kind of the cost-effective ones. Intermittent fasting is cost savings because you're not eating as much. Prayer, meditation doesn't cost you anything. I think sitting in silence for 10, 15, 20, 30 minutes a day is therapeutic. And then the contrast therapy, I think, turns white fat to brown fat, increases your metabolism. And I think those are pretty simple biohacks that are very effective. And I think the clinical data on the outcomes of those are pretty effective as well. And it's indisputable.
Very cool. How about 1 to 2 things people get absolutely wrong regarding longevity and a long health span?
The one size fits all, because what may be beneficial for me may not be beneficial for you based on your underlying cardiovascular risk. I wouldn't recommend people with, congestive heart failure or coronary artery disease do a cold plunge, because it's stressing on the heart. And the last thing you need to do is stress the heart. And then the other thing is, I think the biohacking field is a very important movement because it's making people cognizant of their own biology and how they can do that. The problem I have with it are people with no science, no medical background that are so-called influencers making recommendations to millions of people and influencing millions of people when they just don't have the pedigree, the credentials, or the experience to be making those recommendations. You've got these biohackers out there telling you should take methylene blue every day. And methylene blue is a nitric oxide inhibitor, inhibits nitric oxide production and signaling, and that's not a good thing to do. But yet these people with no credentials, no backgrounds are making recommendations that are hijacking someone's biology, and it could be very dangerous. So I think that's what people get wrong. You can't follow these influencers when they have no science background and don't even understand the science.
Yeah, I think the kind of sad news is with all of this information, you have to do more research, right? So yeah, great. You see a biohacker out there saying methylene blue is good. You got to dig in, roll up your sleeves, and go find the information out for yourself because it is available. It's just harder to get than, doom scrolling.
Yeah.
All right, Dr. Bryan, how can people contact you?
For everything. Yeah, there's a time and a place for everything.
How can people contact you?
Well, I'm searchable on search engines. You can follow me on Instagram, Dr. Nathan S. Bryan, the same on LinkedIn, X or Twitter. I'm Dr. Nitric, YouTube, Dr. Nathan S. Bryan, Nitric Oxide. What else? Buy the book, Secret of Nitric Oxide, Bring the Science to Life. It's a must read, I think. My own personal bias, but anybody who's interested in health and longevity need to understand what nitric oxide is, what it does, and what they may be doing unintentionally to disrupt its production.
They can, is there nathanbryanbooks.com? Is that correct?
Yeah, you can go to nathansbook.com. I have access to it. For those interested in reading the scientific literature, you can go to PubMed and just put in my last name and NS.
Lots of papers
Bryan.
there.
Yeah, over 100 peer-reviewed publications and published papers in the field. It's a very technical scientific paper. But I encourage people to do that. Read the literature.
And then those products are available at n101.com, in
That's
the
right.
number one, O, the 0, O, as in the letter, and then the number one.com.
Right. That's it.
Excellent. And what in the near future are you excited about?
I'm really excited about our drug therapy program because, we've been very successful in bringing nitric oxide products to the market in the consumer world, aesthetics, skincare, beauty, oral care. But I think the future is in safe and effective drug therapy. When I think nitric oxide at the right dose, at the right time, in the right patient, there's not a single indication where it wouldn't be beneficial. So we've got drugs. We're in phase 3 clinical trials now for ischemic heart disease. We're working on a drug for Alzheimer's, a nitric oxide releasing drug that I truly believe is going to eradicate Alzheimer's because it addresses all aspects of Alzheimer's, the metabolic aspects, the focal ischemia and the inflammation, the misfolding of proteins. Nitric oxide completely addresses all the root cause of Alzheimer's. And then we're making a topical drug for, diabetic ulcers and non-healing wounds. And 60,000 Americans die in nursing homes every year from infected wounds. And to me, that's simply unacceptable. And when we get our topical drug approved, I think we'll completely change the world of healthcare and non-healing wounds, diabetic ulcers. I've seen it. I've healed my dad's decubitus ulcers with our nitric oxide products. In fact, there's not been a single wound I haven't been able to heal with our nitric oxide products. And that gets me up every morning with a purpose and with excitement. And I'm just excited to move this through the FDA to get it approved. And I think the political landscape is in our favor now. We've got a lot of champions on the inside, and now's the time.
Excellent. All right. So you can find him by really searching on the platforms for Dr. Nathan Bryan or Dr. Nathan S. Bryan products at n1.com. Dr. Bryan, thank you so much for joining us today.
Thank you, Chris. It's been a pleasure.
I hope you enjoyed this episode of the Live Beyond the Norms podcast. Make sure to subscribe and follow. Also, make sure not to be that guy, the guy sharing this podcast with people who are not interested in living beyond the norms. If you would like to learn more about the ESS60 molecule, the molecule responsible for the single longest longevity experimental result on mammals in history, a full 90% extension of life, visit myvitalc.com. That's myvitalc as in carbon.com.